So there are two ways we can traverse a root or a tree. Like first is DFS, second is BFS. DFS does the depth first traversal of the root, the tree. So for example, let's take this graph because it has more nodes. So we in DFS we start with the first node. We traverse all the way down to its leaf nodes, either the left side or the right side, which is there are like in order, pre-order and post-order traverses. So because I'm visiting the root first, this is a in order this is a pre-order traversal. So I do the root first, then I do the left, then I do the one second, this is a DFS. This doesn't have to be in order, be pre-order or post-order for this. So yeah, I just got confused there. Right, so we are at 5. We simply do a DFS. Let's say we go to 5 to 1. I check the diff. Then I go to 0. I check the diff. I store it here. What does that matter in this case if I do a DFS or BFS? Because I'm going to calculate the diffs anyways for the first tree at least, and probably for the second tree as well. So I guess let's just do iterative BFS for now, and we'll see the solution in the end if there is a better solution available. So because I'm doing a BFS, I need a queue. So in Python you can have a queue like this, which can have the root 1 by default, and then while queue is not empty, I can go and check if the nodes are get the node from that queue dot pop left. Because it's a queue, I'll be popping it from left. Otherwise if I do simply a pop, it will pop it from the right, which is a stack, not a queue. Yeah, I got my node. I need to calculate the node's value, the diff with this node's value. So diff is equal to node dot val, which is getting minused from target. I got my diff, and what do I put in my diff map one? I guess just a diff. Yeah. Which I wonder if I even need the map, because there's nothing. I don't need to care about the indexes. I don't have to return the index, so I can probably use a set instead of a map here, which I could have probably thought of before than now. But yeah, it is what it is. Set 2, fine. We add diff set 1 append. Actually this is a set, so I don't have append there, it's simply called add. So I have added the diff, and if I have a left node in the first tree, then I need to append it to my queue, because we are doing a BFS and I need to go through left and then right of the tree. Yeah, so we add dot left, and the same thing for node dot right. If I have a right node, I add it to node dot right. Right, so this will traverse the first tree, and I can probably make this code a bit reusable, and then yeah, probably move it to a separate method or something. But for now, to keep it faster, I would just repeat myself here, which is not good in normal life. Right, so I need to reset my queue to the root 2, which is my second tree. Again, the same thing. I can even copy paste this. There's one difference, which is instead of adding it to set 1, I need to add to set 2. Then actually, instead of like having, I mean, let's say for till here we are good, we want to do it this way. We have the diffs going into the set, and what we need to check if the current number is present in the set 1, because that way we can notice, like let's say I want to see if my current number 3 is already present in that set. That means in the first set, that means there was a number which was subtracted from target, was giving me this number. That means that plus the previous number is giving me my current target. In that case, I need to return true. So I think while traversing the second tree, we can simply check if I ran it by mistake, my bad. So while we are calculating the diff for the second tree, we can say if the node dot value for current tree in my def set 1, then I simply return true. Yeah, otherwise I just keep on traversing my tree, and in the last, if I don't find a fulfilling pair, I can return false. Yeah, so the second thing that they usually ask you to do in interviews, especially with some of the big techs, is they will make you walk through the code, and some of them don't even make you run the code. So let's run through the code. Just walk through the code, I mean. Right, so we have so we need to be a human debugger in this case. So because we don't have the luxury of having a debugger in such interviews, let's put all the call stack variables we can see here. My queue as well. Currently my queues, let's say, traversing the first tree. We have appended it with the current root, which is 2. I'm just putting a value of 2 here just for the example, because my current tree is having 2. Then I have my left and right, which I can probably not have it stored here, and then I have my diff, which is at this current tree would be 5 target, which is my target, minus 2 would be 3. I would add that to my diff. Right. Similarly, I continue for left and the right, which would be every time I process this diff, my queue would be added with the left and then the right. So 4, so 3 comma 4, and then again at the right, 5 minus 4 is 1. Right. So add that to my diff as well. Now the time is for the Q2. So instead of like having this Q2 confuse us, I can remove it. My root node is here. The target minus 5 is 4. I add it here because my current number doesn't exist in the previous set. Right. And then I go to my next number, which is left, which is 0. Q is obviously having 0 here now. Then my diff is 5. 5 doesn't, or the 0 doesn't exist in the diff yet, diff 1 yet. Add it there. Push my I append my 3 to my right, the right side of the node to the queue. 3, which is giving me a 2. Do I have 3 in the first set? Yes, I do. That means we found a pair where we are able to calculate the sum as given target, which is 5. So 3 plus 2 is 5. So yeah, in that case we are returning true. But let's say that condition didn't trigger at all for all the items in the second tree, then yeah, we are returning false in the end. Yeah, we can try to run this code, and I guess we have already done the time complexity analysis, but yeah, we'll come to it again. Right, it passed very well. I guess since we have done this, one thing we would or I guess you should probably explain while you are giving an interview that this could be cleaned up. So instead of having this code written twice, we can probably just move it to its own method self. Then because I need to have my diff set updated whenever I do this BFS, and obviously I need the root of both of the trees when I do that. But yeah, there's a catch. You need to do this thing, especially this thing, only for the second tree. So yeah, I guess let's just leave it here and we can submit it. Yeah, I mean it works, not super clean, but yeah, it should work. Yeah, it beats 100%. Nice. That's a good one. Okay, that's the solution I came up with. Let's see what the Leetcode tell us. Because they have because I do have a premium subscription of this platform, which is obviously burning money, but I have it. Yeah, so they are saying they have this DFS based solution, and what are they doing? Do Sum BST takes a target, takes a root 1, root 2, then they have defined the DFS node list. If not, current node return fine, node list dot append, current node dot value, node list dot append. Okay, they are maintaining a node list. Okay, interesting. Yeah, they have initialized two lists, node 1, node 2, and then they're doing DFS on both of those nodes, and then they're adding all the values to that list, and then yeah, basically doing a sum on the target, a sum of both of the values, and seeing, okay, that's fair enough. Similar to what we did. Instead of like having the lists, we had the sets, which is, I guess, okay in this case. Then they are talking about binary search, which I assume would be, yeah, definitely. Oh well, actually not really. We are doing it in O of m plus n time, and they are doing it with m log n. So I guess we are still doing fine. Okay, that's actually okay. They do have a hash set best solution as well, right? Yeah, similar to what we did. And yeah, right, we actually came up with the actual optimal solution, which was a nice win, I would say. Yeah, did it. I mean, this is a proof anyways, so good work. Alright, that's it for now. See you.